Hi, everybody, and welcome on the Lights on Data show.
Woohoo!
My name is George.
I am Diana.
And, well, here's everybody. Why don't we do a round of introductions? And Joe, why don't we start with you?
Hey, what's up? Joe Reese, recovering data scientist. Also run Ternary Data, and just one of the also a member of this clan we got here, the Data Heretics. So I think we'll be here to drop some heretical knowledge on people. It should be fun.
Awesome. And we'll take you, just randomly. Danny, you are next.
Hello, everybody. Thank you, George and Diana, for having us live with you guys. So my name is Danny Ma. Oh, thank you. My name is Danny Ma, and I run the Data with Danny virtual data apprenticeship sort of thing, doing online courses at the moment, and I enjoy posting memes and free Udemy courses on LinkedIn.
Those always make us laugh. Keep on posting.
Thank you.
And Dave.
Hi, my name is Dave Langer. I am an ancient programmer, and I like analytics. and I'm happy to be on the show. Thank you, George and Diana. I appreciate it.
Thank you as well. Here. And Koo.
Hello everyone.
Yes,
there you go. Everyone. Yeah, if you know, am I like? Oh yeah. Hey, hi everyone. Yeah. So from Singapore, Asian country. So I do consulting and training work in data science and AI over here in Singapore. And that's my daytime job. My nighttime job, I actually run communities, tech communities over here. So far I'm running like 2 tech communities over here. So hi everyone, and nice to be on the show.
Thank you very much for being here. I'm very curious to find out a little bit about your name. So you could have called yourself, I don't know, the 4 Musketeers of Data, or you could call yourself in very many ways. Why did you choose the Data Heretics?
Let me maybe add a humorous angle to it. If we call ourselves the 4 Musketeers, then we probably have to choose like which character we want to be. I'm pretty sure there's one that no one wants to be. Yeah.
I recall it was Dave had. I think he called himself a data heretic. Am I mistaken in that, Dave? That used to be, or maybe it's still your title. I mean, but then we just somehow incorporated it to include all of us, I guess. I'm not sure how that happened, but I'm pretty happy about the result. So
I know that I think Dave says, from what I read, that you have a heretical belief that any professional can learn valuable data analysis skills, right? So that's where it all started.
I've kind of softened it a bit over time.
Mm-hmm.
I mean, if you check out like my LinkedIn stuff from way back, I would have posts that basically say things like "step away from the deep neural network." You're not going to need it, right? Things like that. So I've kind of softened it a little bit, but generally speaking, it's this idea of most of the stuff that you see in the Facebook or LinkedIn feed regarding AI and analytics and machine learning, all that kind of stuff, is hogwash for the vast majority of people. Basically, is the idea.
Mm-hmm. So, Joe here could have started a music band, for example, but still he chose this wonderful group. So what is the purpose? Or what is the vision of the Data Heretics?
By the way, can I just interject real quick?
Yeah, please.
Diana, Brainwave, the Data Swashbucklers. Thank you for the idea. Mucho appreciated.
The vision of it's interesting. I mean, I think we randomly, got together and did a show, and people liked it, and then we did another show, and people liked that, and we kept doing shows, and sadly we skipped one in I think March, but we've been, I think, as consistent as 4 busy people can be. But the vision, I think, is the first episode I think really hit it on the head, where we were dispelling a lot of data myths. Right, sort of myth busting for data, and I think that's maybe one of the overarching goals. I'll let the others, add some color commentary.
Awesome. We also want to open it up here for a Q&A, as you have access to amazing for data scientists. So it's free for all. We're going to, just pick and choose the questions as they come in. But, to your point, Joe, yes, it's not easy to get this group together. I mean, I know we've arranged this a couple of months ago, I think, and to do this in 5 different time zones, 4 different countries, 3 different continents. It's definitely not easy to get the group together. So we really appreciate your time and coming in to be on the show.
And we invite our audience to ask questions.
Yes. And I wanted to start us off with this. As somebody that wants to get into data science, of course, they need to follow each one of you, as you're all providing amazing, valuable content there. But where do you recommend they would start? What sort of skills should they try and harness first? Or is there a particular one, or is it, a set of skills that they need to harness in parallel?
Let's see. Oh,
Like
you take this on. Cool.
No, Danny, you can go first then. Danny, yeah.
Okay. So for me, I think that for anyone trying to become a data scientist, the first thing that comes to mind is being great with data. So the things that we traditionally recommend people to get a good grasp of before they start interviewing for data science roles is usually SQL or SQL is probably the main one. You see in all of the big FANG companies, SQL is predominantly the tool that they use to extract the data that they'll be using for all sorts of other things downstream. Oh, that's my website. It looks a little bit funny.
I wanted to bring this up to definitely check it out, datawithdanny.com. Amazing, great content there. And also check out the YouTube channel too.
Thank you so much.
Sorry for interrupting, Danny.
No worries at all. I think there's something wrong with my website. It's supposed to be in dark mode, but something is... Anyway, I'll fix that later.
We like it anyway. No worries.
Still good.
We don't know it has to be dark.
But yeah, I would say SQL is probably the main thing that people should cover. And then after doing that, or in parallel, they can keep learning the main data science programs that we like to use as well in the industry. So these can be Python or R. They're very, very popular. But I think there's also the theoretical side of the data science as well. So we're thinking about statistics, problem solving, critical thinking. Some of these things you gain by working on more problems. So usually we'd recommend people to try and tackle some portfolio projects that incorporate some of these aspects into their resume or CV or different things like that, and try and build out a portfolio. Those would usually be the key steps that we would recommend to people trying to break into data science.
Amazing. Mm-hmm. Thank you. Anybody else from your experience want to add anything else, or something that another order in which you've tackled things, Dave?
So here comes the heretical part. Don't do it. Don't do it. Don't do it. If you want to become a quote unquote data scientist, it's so hard. The competition is so very, very stiff these days. So really ask yourself, first and foremost, do I need that title, or I'm interested in solving business problems with data? That's the first question I would ask. Mm-hmm. And if the answer is yes, you can totally do it in your current role, more than likely, whether you work in marketing, supply chain, IT, finance, who knows, right? Start doing data analysis in your current role, see if you like it. And then if you do, and you say, I want a formalized role, don't go for the data scientist title. Look for an analyst, a technical analyst role in a company. And for God's sakes, avoid FANG. Look for companies way outside of FANG to get started, because the competition is going to be a lot lower.
And I just wanted to interject and mention, check out davondata.com, as it's full of amazing content too. And of course, David's YouTube channel as well.
When I was reading about you guys, I said, Data with Danny, Dave on Data. We could have Deanna and Data. We can just have George and Data, because George's name doesn't start with a D. So too bad.
But, is this statistic still true that there's still a high demand of data scientists? And the education sector just can't supply enough of data scientists? Yeah, do you find that's the case?
You know, sorry, I think it's not that split hairs, but I think it does depend what we're defining as a data scientist these days too. Hey, Scott Taylor, what up, guys? But the title, I think, is morphed into something a bit different than it used to be, maybe even a few years ago, right? And so, and then as Dave and Danny point out too, there's different maybe requirements depending on where you want to work and what you want to do, and so it's and so the needs, I would say, for people who are data literate are still really high. But functionally, what that role entails, I can make an argument that maybe there's a glut depending on who you're looking for, and maybe there's a shortage depending on what you're looking for. And so,
so let's talk about that. Let's define really what data scientist means to you guys, because as you mentioned, it did change, and I've recently released this video that compares the data analyst versus the data scientist, because there's total confusion out there. And I mean, even in my explanation, I don't think it's 100% foolproof, because there's still some sort of an overlap, and then it also depends how the organization sees these roles and different responsibilities. So from your experience, what do you see as a data scientist?
Maybe let me add on to that, because I did a short article on it. So at least from my viewpoint, is how I define data analyst or data scientist, right? Is I'm sure most of us have heard about this thing called the 4 types of analytics, where you have the descriptive, diagnostics, predictive, and prescriptive. So that's at 4 levels. So I would say the data analyst is more focused on the first 2 levels, the descriptive and the diagnostic. So the analysis skill is actually the demand on the analysis skill is actually quite high for the data analyst. Then for the data scientists itself, they will be a bit more focused on the level 3 and the level 4 predictive and prescriptive analytics. So they will be using more on the algorithms, machine learning, and all these, right, to extract value from the data. But at the end of the day, data analysts and data scientists, right, to me, I don't see there's like one is higher than the other. Both of them, I see them as performing at the same level because of the skills that they require, and the way they also
focus.
Yes, correct. And but at the end of the day, regardless whether you're a data analyst, data scientist, or whatever title that you hold yourself, if you can't extract value for your company, it's just a title.
Absolutely. And in the end, if you enjoy what you're doing, I mean, that's what matters most.
Yes.
I feel.
Correct.
Right.
It's a long journey, It's a long journey. So you have to enjoy what you're doing. You have to enjoy learning as well. Yeah.
Absolutely.
I would say for me, my experience, right? So take it as one data point. 6 or 7 years ago, there wasn't such a heavy focus on machine learning necessarily, and there definitely wasn't such a heavy focus on building and maintaining production code for machine learning models. So I think you're starting to see ML engineers break off now, because like data scientists move from a more general, very technical data analyst person, right? The old adage was you knew more stats than any programmer, and you knew more coding than any statistician. That was the data scientist. Oh, you threw in some business knowledge. And that's kind of shifted now, because everyone's like, oh, it's all about machine learning, which is cool. There's nothing wrong with machine learning. I like it as well. But I think, as Joe alluded to, the pool of ROI, return on investment, that's available to organizations is vast, and it isn't focused on having a data scientist put a machine learning model in production. It's having a data literate workforce.
Mm-hmm. Yeah, I remember, I guess the work I'd been doing for a long time had been called data science, but I remember when data science, I think that's where maybe our experience is different, but I remember when it was in the early 2010s, especially, it was like all about machine learning. And actually the word analyst was like a 4-letter word. Like you could never call somebody an analyst, because that's like calling them like an inferior human being almost. Like analyst wasn't, it fell out of popularity amongst like the cool data science crowd for a bit. But I think what happened was data science, I think, got off to a bit of a rough start, because as was indicated by Dave, productionizing machine learning models, getting the data to even do machine learning, like that was the crux. And so a lot of these data scientists, several years ago were hired in these companies and were basically just sitting idle. They weren't doing much. They're actually having to set up the infrastructure in order to, make it so they could do their jobs they're hired to do. And that doesn't even take into account productionizing models. So I think only recently, but at the same time, what you saw, the reason I come back to it, it kind of depends on what the title means is, companies, I think back, at least when I was, starting to do ML, like data scientist was an ML type of role. But then in order to make yourself look cool as a company, you would have these job postings where you're hiring for a data scientist. And that slowly began to encompass all sorts of different roles, analysts and, anything else that had to do with data, probably data entry or something, data scientist role. So if I had the word data, now you're a data scientist, I guess, right? But
I'll just throw my 2 cents in before we move on to like another question, maybe.
Yes.
I recently put out a video from one of my old live streams that talked about different types of data scientists. So in my mind, I feel that with the breakaway from like there's the traditional data analyst who's just very, very technical. That would be one type called the A type. The B type would be the building type, where it's essentially a machine learning engineer these days, where they're very, very software focused. And the last one would be more of a consultant. So these days we're seeing like a data science, I would call them like data science product managers or product owners who have some of the experience doing the technical stuff, but they have much more engagement with the business. Mm-hmm. So I feel that these are the three current delineations. And if you can do all three of them, then you can call yourself a unicorn. But how many of those people actually exist in the world? I would be able to probably count them on my hand or something like that. But yeah, I'll throw my words into the ring.
Thank you. Yeah, I was going to ask what you're calling the ones that overlap, and I think the unicorn is the perfect analogy and example. Just wanted to mention, if you haven't checked out Ternary Data, which is Joe's YouTube channel here, please do subscribe, obviously, as well as the other channels, and lots of great content, of course.
Oh, thank you.
And cool, I don't know, do you have a YouTube channel as well?
No, not at the moment, planning to, but my community work is actually taking up a lot of time, a lot of my time rather these days. But I have a podcast channel.
You were the founder organizer of the data science in Singapore.
Yes.
So you guys are doing a lot of great stuff there.
Yep. So that's one of the community work. The other one is actually a recent one that I set up. Is called AI Professionals Association. So it's a bit more sort of also catering to the employers as well, helping them to sort of deploy or build up their data capabilities. So those are the two. Yeah.
Thank you. Okay.
Thanks, George, for sharing.
That one up. So let's take a couple more questions. We have one here from Baby Valikala. How much coding would be needed to be prepared for the data analyst or the data science interviews? Coding in the sense of what concepts should be mastered in order to clear the interviews, and then I guess you can learn on the job as well. But what sort of languages or how advanced should you be in those coding principles to just pass the interview, do you think?
Unfortunately, the answer is, and this is going to sound very weaselly, it really depends on the hiring manager and the position. It really, really does. Because that can range all the way from, like, if you go for a data scientist interview for, let's say, like a FANG-like company, where they're expecting you to write production quality code and maintain it in Python for a data scientist job. That could happen. Whereas you could go for a data analyst position, they wouldn't even ask you any questions at all about programming. They would just ask you about stats and what you can do in Excel, do you know some SQL, that kind of thing. So it really, really runs the gamut. What I would say is, based on my experience and based on the folks that I talk to and mentor, if you go outside of the tech companies, the programming bar gets lowered dramatically. That's what I was talking about earlier, is that it helps you out a lot from a competition perspective if you target some of these companies that aren't in like the first tier tech space.
Mm-hmm. Thank you. So, Baby, I hope that answers the question.
I think who wants
Maybe
to
let me add
answer?
a bit more to that. So
Yes,
I think
please.
the other thing is you can see it from the other way around and pick up a few of the more important language and use it to sort of filter which are the companies you want to work with. So I think the companies that are sort of like quite serious when it comes to data work and all this, they probably would have would need you to know SQL and also Python or R at the very least. I think these three languages will be something that you should focus on as well. And just a shameless plug for Danny and Dave will be, you can take the SQL course from Danny and R and Excel from Dave courses.
Absolutely.
But the question is interesting though, because also at the end it asks what concepts need to be mastered to clear interviews, and I would think that it's actually a pretty salient point, right? So you're talking about concepts, maybe we could talk about that for a sec too, because I think it's a subtle point, but there's something to unpack there. So if you're able to perhaps, so I see this a lot, like fire up a notebook, whether it's R or Python, be able to make charts, right? So be able to visually display information. That's one concept. Maybe understand what types of visualizations are appropriate for the type of problem you're describing. That's another one. And then I would also think being able to use the language that you're interviewing for in order to describe statistical concepts, right? So, are you able to do something as basic as just make a histogram or something like that and describe data and summarize data and make it useful, right? And be able to convey those concepts, with code. I don't think too often you're going to get questions on, how to make like a sorting algorithm or something, right? It's like a data science interview. Now, if you're interviewing for software engineering position, yeah, probably. So those are maybe some areas to focus on, but typically it'll just be like pretty. I mean, as Dave pointed out, it's pretty practical, kind of hands-on stuff, right? So, but that said,
just
know your company.
Yeah, just to add on to what Joe's saying, concepts. Can you analyze data? Okay, first and foremost, even if it's in Excel, right? Can you create the data visualizations that Joe was saying, even in Excel? Can you pivot tables? Can you use pivot tables? Can you just do some basic data analysis and then worry about tools later? So, for example, I teach folks how to do linear regression in Excel because it works just fine for a huge number of scenarios. You don't need to worry about it. And then if you need to learn R or Python and do linear regression in R or Python later, because that's what a job requires, great. But learn how to do it first. Learn how to analyze data first, and then worry about the tools later. And if I may add something heretical again, I'm going to look directly at all hiring managers out there. Stop with the SQL leet code stuff, okay? I wouldn't be able to pass it, and I've been writing SQL for more than 20 years. Okay, it doesn't matter. It's not going to tell you anything. Okay, I'm done.
Good point.
Can I add for the on Joe's point too about the salientness? Is that the word? The importance of what concepts you should know. I think definitely being able to analyze data is going to be a core thing. Using whatever tools are at your disposal. Another thing would be analyzing data is one thing, but then trying to come up with a conclusion or some sort of action off the back of it is something that we're usually looking out for. A lot of the times you tell someone to analyze the data, they give you a few charts, but then they can't back it up with what does this mean for the business? How can you take it and generate value using your insight? Different things like that. I think that's more of like I'd call it almost a soft skill, which you develop over time working in the industry, where it's almost like the so what factor. This is a really good chart, but so what? I think that's going to be something that really helps people differentiate between like someone who can analyze data and someone who can analyze data and bring value from it. I think that's what a lot of the hiring managers out there who are doing all the LeetCode SQL things may or may not be looking for. I would also say for another really important concept to know for any of these coding, or like even if it's just a technical chat as opposed to an actual technical coding interview, would usually joining things is really important. Joining things, aggregating things, looking at things over time, aggregating things over time. These are the things that we do on like a multiple times a day basis when we're working as a data analyst or a data scientist. So I think those are the main concepts that I'd try and cover before going into any of those interviews. But as always, it really depends on the company, the hiring manager, even the industry that the company is in. You could have specific challenges, like a digital e-commerce company is going to be very different to, let's say, a pharmaceutical company or different things like that. So it's really good to do research on the target audience or the target audience from the hiring manager, as well as the target industry that you want to work in. So try and think a little bit outside the box for those sorts of things when you're preparing for interviews.
Awesome.
If I may add also, I think the other thing that is quite valuable, right, is actually being able to access how you actually convert a business question to a data and maths question, so to speak. I think that gap itself is actually quite wide these days, and it's something that probably a lot of boot camps doesn't really cover. So what do I mean by that is, let's say now business stakeholders usually will just give you a business question. They say that, hey, I like to maybe increase my sales for the next 1 month or so, and these are the data that I have. The data scientists will probably have to make an assessment whether there's like a data problem fit, whether the data can actually answer the problem, and how do you answer it with the data and all this. So I think that gap, that thought process is still not taught that much in most of the courses and boot camps that I come across. It could be because it's not easy to teach. That will be one. But I think it shouldn't be a showstopper for anyone who wants to join the field. And personally, I feel if you really want to be able to sort of see that gap, right, is really do a lot of hands-on, like what Danny and every one of us have been, Danny, Joe, and Dave every one of us has been sharing these days. Start working. You can read a lot, but you have to start working on something. Then you can see how all the different tools will fit in together. Yeah.
However, this is the hardest to train, right? So I can learn Python, I can learn R, I can learn SQL, but who or how am I going to learn to answer those business questions actually? So I think that's something that comes more, with experience, with soft skills and so on. And
yeah. We have another question here from Ebru. And sorry if I'm mispronouncing your name, Ebru. Hello, what do you think of everyone wants to do the model work, not the data work? Data Cascades in High Stakes AI published by Google last week. How can we resolve the growing data engineering and analysis work?
Let me take this. Stop making data scientists the sexiest job of the 21st century or whatever century that we are in. I always joke with other people. I say that seriously, we data scientists are not that sexy in the first place. I mean, you look at the four of us. At least for me, I'm definitely not sexy. If you're going to have a full body shot of me, yeah. So no, yeah. So stop making data scientists like the sexiest job. I actually feel that data science or artificial intelligence, whatever that we're discussing, when it comes to data, right, it's actually a team effort. There's no one better than the other or whatever. I kind of feel everyone has a role to play. So everyone just play their own role. And yeah, don't have to focus yourself on being a data scientist. I think the other roles like machine learning engineers, data engineers. I even recently, I think I read something about AI ops. I still have to dig deeper about it, but I think really we need to everyone play our role. And when I say everyone play our role, not selfishly but also collaboratively as well. So we help each other out as much as possible, because we won't know everything. Yeah, we won't know everything. So let's help each other out. Yeah.
Yeah.
That's a wonderful message to get across. And I think you're all amazing. You're all sharing stuff. You're all really giving back to the community. And I wanted to ask you something, but I think, Joe, you wanted to say something.
Well, I mean, this paper, I like what Google's putting out. I mean, they had the machine learning, the high interest credit card out of ML like a few years ago. Then this recent paper, everyone wants to do the model work, not the data work, that came out recently too, I think within the last month or two. I remember reading it, and I thought it was interesting. It definitely highlights, I would say, a lot of the things that I've experienced as well, where, so they talk about data cascades where, I think issues, kind of upstream cascade down, and affect just machine learning, processes. And so a lot of that comes down to data literacy and kind of intangible factors that are just hard to figure out, right? But I think, as everyone points out here, everyone wants to do the sexiest job of the 21st century, which is making models and not putting in the work to do all the other stuff, like setting up production machine learning processes and communicating, like pretty simple stuff that you should do just as a business. And the other interesting things about this, so you ask about, resolve the growing data engineering, analysis. I assume you mean gap between the two. It's interesting. I mean, having been a data scientist, I call myself a recovering data scientist because I spend a lot more time working in data engineering now. I would say I'm probably not a data scientist at this point. Even though I have significant experience and training in it, I wouldn't call myself one at this point. I think I'm much more of a data engineer. But that's precisely because I realized that, early on, having worked on, ML at a very early stage, like, all the problems that I was working with in ML had nothing to do with the algorithms. It had everything to do with the pipelines, pre and post machine learning. So that was my early insight into it. And I guess I've kind of deviated. So this paper really resonated with me, just because it's my experience. I think a lot of the stuff is so often ignored because a lot of data science right now focuses on all the cool stuff, like let's build models and all that. But I think, the field of machine learning and data science is evolving quite rapidly. Creating models is not the problem that it used to be even a few years ago. It's a very much solved problem for the most part. I would say for a lot of use cases, you can find a framework that'll probably address your needs more or less, right? And now the issue is, how do you productionize this stuff? So you're starting to see ML engineering explode and ML ops. Shout out to the ML ops community. I think they're doing a fantastic job. Trying to wrangle this beast. There's a lot of activity in the ML ops space. I think that's the space where I'd be paying attention to as a data scientist. It's not even the model building. I think there's a lot of people doing that right now. It's all the other stuff that's going to hopefully solve a lot of the problems that were talked about in this paper.
So then, Joe, from your experience in the data engineering field, do you feel that with all these modern tools and solutions on data virtualization and virtualization, I said, okay. Right?
Yeah.
Are really maybe the role of the data engineer is slowly changing as maybe that ability to build data pipelines is being put in the hands of the data user more. And then, the role of the data engineer is trying to change as a result as well.
It is.
And maybe shifting towards that ML engineering, for example.
I think the role of the data engineering is, so I define the role of a data engineer as basically being from taking data from source systems to the point where you make them useful for a data scientist or a data analyst, right? So it's that pipeline. And after that, though, the data scientists, and sort of that feedback loop with machine learning, like that's more of kind of the ML engineering space, because that's an entirely different pipeline. And so, I was actually writing about this morning. So I'm writing a book for O'Reilly on data engineering. And this exact topic was something I've been fixated on all day, which is, okay, the role of data engineering has changed. It's not so much, are you a big data engineer anymore? Because I think that's a very much, again, a solved problem. Distributed systems have become managed services, third-party services, et cetera. The question now is, are you able to architect pipelines and infrastructure in such a way that it's scalable, reliable, and gets data scientists and analysts the data they need, and is also configurable in light of basically this a never-ending series of tools and new methodologies coming out in the data engineering space that by the time you've implemented a tool, there might be a different one out, right? And so you got to be very flexible and very agile in your approach. So I think that's that framework of understanding the data engineering lifecycle and be able to figure out the best tools for the job. I think that's more of where the role of a data engineer is heading.
Danny, what do you think with this thing's happening? Will SQL just become more of a niche for people that need to do things that you wouldn't be able to do with like drag and drop tools, so to speak? Or
I'll try and be quick so Dave can get his words in too. So my career journey so far is I've essentially been following Joe's career. I'm just like a few years behind him. So I moved from working in data science to then moving more into an engineering role after seeing the real need to actually work with all these different teams to get the data in the way that the data scientists can actually consume. So, and then there's also the downstream stuff about the ML ops and everything like that. This is like my bad prediction for the future, but I feel that there'll be more, it's almost like a maturity curve where you start off data analyst, you want to become a data scientist because it's cool and sexy and you get to use different tools. Then after that, you realize, I want to put my models into production. I have to work with the engineers to put it into production. And then you realize, the problems that I was solving in data science aren't actually that challenging compared to what I need to solve in the engineering space. And then you kind of become engrossed in that. And then you call yourself an engineer by the end of it. But I feel that having that experience of knowing the different roles and the different requirements and different things that you need to perform really gives you good insight and knowledge to actually help the engineering teams make the thing happen. So as a business owner or an entrepreneurial type data scientist, that's the thing that you really want to go after. So whether it'll become more of a niche or whether it's going to become more of the norm, I'm still not quite sure. I hope that it's not going to become the norm because that's kind of our area of specialty. So, but hopefully more people can see the importance of the engineering components, whether it's upstream, getting data from source, or downstream, making everything run efficiently so you can quickly retrain models, redeploy, get new things in, and build more models at scale.
Absolutely. And Dave.
Yeah, so this is where I put my Gandalf big hat on and I do the ancient programmer thing. First up, for the original question, there was a study done like 20-something years ago now, back when all this was called data mining. And what they said was, even then, 60 to 80% of a data mining project was data management activities, acquiring data, cleaning data, getting data, understanding data, blah, 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 blah. So from that perspective, at base, you can make an argument that that's never gone away. If folks just want to do modeling, what they've done is they've lost touch with the reality of what the work really is, first and foremost. And then second of all, what I really want to talk about right now is riffing on what Joe said when he was talking about data engineering. The whole thing about big data, do you guys remember that? Remember when that was a thing? Big data. Do you have big data? I want big data. Let's have big data. We need big data. The whole idea there from a software engineering perspective was big data was interesting because from an engineering perspective, it had very profound implications on your non-functional requirements for the solutions and systems that you would develop. However, all the stuff that Joe talked about, none of that's new. It's existed for a long time. Back in the old days, big data was something like a Teradata system where you'd be working with maybe a petabyte of data or something like that on a big old Teradata cluster. All the same concepts still apply. So a lot of this stuff isn't really all that new for the vast majority of companies because they don't truly have big data. They truly don't have the non-functional requirements. Not everybody needs a Spark cluster to build ETL pipelines. They just don't need it. So all that to say is that, getting back to the original question, it's unfortunate if that's the reality, that people are moving away from the fundamentals and just focusing on machine learning, because machine learning is such a small part of it. So here's what I find sexy, by the way, just so you know. I'm going to go ahead and find our best customers in terms of their demographic characteristics, in terms of paid conversion, and find out where in the United States they live so I can target them. Do you think business people find that sexy? You're damn right they do.
I think so, yeah.
And you don't need any machine learning for that.
Yeah, I think it's interesting. There's a lot of cargo culting, I think, in just in data in general, right? Dave brought up Dave on big data, and there was definitely a time. I remember when people would spin up these Hadoop clusters and they'd have like a gig of data in there or something pathetic. But it was just because you could say to your friends like, yeah, I'm like running Hadoop now, pretty cool. But a lot of that's being abstracted, right? I mean, what abstracted a lot of this was the rise of the cloud. And then data warehousing was cool again. There was a time when data warehousing was actually out of fashion too. You brought up Teradata, and like that was expensive. Then Redshift comes along, and then it's like $100, $150 a month, like run a node, the cloud data warehouse. And then you started seeing this like evolution back to SQL again, which I think is kind of interesting as well. So to riff on what Dave's saying, what's old is new again, and but things always get abstracted. But I think the salient point here as well is that data quality issues, I think, are going to become more. There's going to be more of a spotlight because there's not as many places to hide anymore, right? Because you've already solved the data pipeline piece. I think that's increasingly becoming. There's a lot of companies in the space right now trying to abstract this, right? And then every layer is going to be abstracted, but the hard part is always the fundamental issue, which is data quality, right? And data management. I suspect that these roles like data engineering, software engineering, even ML engineering, I have this crazy prediction that in about 5-10 years, actually these roles will be the same. Because data is an asset that you really can't escape from, right? And so if people try and pawn it off, like, oh yeah, well, I'm the software engineer, I just like make the data and give it to the data engineer. The data engineer is like, well, I take the data and I give it to the data scientist and they can deal with that, right? But the chain of custody is such that, I think at some point, because everything is going to be data driven, there's going to be a feedback loop. The roles are all going to be pretty much the same.
Yeah, I think that's a great point because I would offer this up for folks for consideration. If you're going to be in analytics, right? If you want to use data to solve business problems, you're rarely going to be able to 100% rely on the data engineering team or the ML ops team or anybody else to allow you to be as agile as you need to be. So for example, maybe I decide I get a hypothesis in my head and I want to test it out. So I'm going to go to data.gov in the United States, pull down a bunch of data, or maybe I'm going to go get a REST API that source some data from like Twitter or maybe a SaaS product that we're using. And I'm not going to want to wait for the data engineering team to prioritize that work and get it in place. I'm still going to need to do it myself. So from that perspective, once again, the data mining survey study that they did way back in the day that said 68% of the time you're working with data, that's, in my opinion, in my experience, that's not going to change. So all these roles and things are great. Data management is great. And analytics professionals that are interested in being agile and making impact as quickly as they can are still going to need to worry about working with data directly, cleaning it, acquiring it, understanding it, no matter what.
So Dave, are you saying that the bottleneck is maybe on the data engineering side of things right now?
Oh, okay. So no, that's a great question. My answer might be heretical. So like, as Joe's pointed out many times, I'm old. So I've been a traditional DW BI kind of person before. And yeah, that's always a problem, right? That's always a problem. If you need to wait on another team to give you data, and that's a blocking point for you as an analyst or an analytics type person, yeah, that's always going to be a blocker. One time, and this is a true story, I worked with a PhD econometrician who was hired in a data science kind of role, but he didn't know SQL, he didn't know how to code, he didn't know how to source his own data. So he was always hemmed in by his inability to get data. So he had to rely on other people to do it. So don't be like that. Don't make the mistake of just focusing on machine learning and only doing that. You need more skills than that to be effective.
But so I want to ask you all of you this. Isn't this more of a lone wolf method? Let's try and solve the problem ourselves. When shouldn't maybe the awareness just be added on the company and for the company to figure it out, this resourcing issue?
Spoken like somebody steeped in enterprise data management, George.
I feel that
So-
lone
Yep.
wolf might be more on the negative end of the spectrum of descriptions for what type of person this should be. It could be more of like a art. Like I've heard of this type of skill set as being more like an artisan, where you can really take control of everything in the process.
I like that. Yeah.
When we think of let's say you're running your business, you need to hire your first data scientist. You want an artisan because chances are you don't have any idea what's going on. You need someone to help you sort it out and do everything.
You need a Swiss Army knife type of a person.
Exactly. Whilst when you're working in larger organizations where things are a bit more robust and there's different departments that handle different things and different functions that should do the data management, the data validation, the engineering, all the pipeline building, then you can afford to have more specialized roles. But even then, for someone coming into one of those roles, it gives you much more utility and value if you can come in with some of those artisan type skills. They'll help you be able to link up with teams better and move things along faster. Which should be important to middle management, but sometimes, unfortunately, it's not always like that. But I feel that, I think lone wolf might seem appealing to some people. I think more of like an artisan trying to control everything, well, maybe not overly control everything, but just have a good oversight over everything that's being done and be able to do it yourself is very, very valuable.
Yeah, when I think of like lone wolf, I think of like a wolf stranded in the Arctic, like with no food and like no sunlight. So, when I hear lone wolf, I think of that because you see this in I guess it's a data team of one, right? Because you're going to hire this lone wolf, and this person's supposedly going to figure. I can't count how many times I've seen this in places, and inevitably the result is lone wolf ends up looking for another job at some point. Occasionally, I would say lone wolf is successful, but that also entails that lone wolf gets the data, and the data is in good shape, and they're actually able to do stuff with it and so forth. But you hit on the artisan thing. I think who was it? John Thompson's book talked about that. Yeah,
Yep. It was John Thompson.
Yeah, it was. Yeah, shout out to him. Great book. Y'all should buy it. If you're gonna build a data science team, I'd say go get his book and then go build a data science team. Or don't buy his book and build a data science team. I don't really care.
So if I can, I was a bit cheeky with you, George. I apologize. But here's what I would offer up for consideration. And I'm going to go back to the big data era for this terminology. What is the value density of the data? So for example, if I'm exploring a hypothesis or an idea as an analytics professional, I might not know what the value density of the data is until I actually play around with it. So there's actually no point in putting it in the enterprise data management pipeline because of the cost until I find out what the value is. So if you want to consider that lone wolf, okay, then I'm Joe's lone wolf up in the Arctic, all alone and sad.
I actually like that a lot.
I got my data.
It reminds me of like the caloric density of foods and stuff, or nutritional density, kind of the same thing. Like you could have your Big Mac over there, or like your bag of Skittles, or like your kale salad or whatever it is. So
I think
I have to ponder that a lot.
Sorry, if I may add, so like recently, in fact, it was yesterday. Yesterday, I was speaking to a friend of mine. Unfortunately, what happened was the company, it was a startup company. So what they did was they thought that, hey, I like to do some analysis of my data, do some data work and all this. And they went ahead and actually hired my friend as a data scientist. But unfortunately, what happened was that when my friend actually entered into that startup, right? The startup actually told him that, hey, this is the green field. You can go ahead and see what are the things you can do with our data. And there wasn't much planning and all this, unfortunately. So my friend actually had to struggle to go and find use cases and all to understand. And then on the flip side, the companies is still like waiting. Hey, when can we see some use case? When can we see some value out from our data and hiring and all this? At the end of the day, I do agree. I think the artisan approach will be like you need to have someone who has a sort of a very general experience first, who know how to get the use cases, who knows how, like, what are the pipelines you need to lay out and all this first, before you really start hiring. I wouldn't recommend any companies, right? As long as you think that, hey, I got data, you can immediately go and hire a data scientist to work magic for you. That's not going to happen. We data scientists work with data. We don't work with magic powders. we can't suddenly conjure
Speak
something
for
up.
yourself, Ku.
Oops. Okay. So anyway, yeah. So I'm more of an advocate for planning. If don't just say that, hey, I got data and then let's do it, that kind. No, I think it's good to have to plan it out first. I think it's best to hire a consultant to have a look at the landscape and all this first, decide like what are the things you can do and cannot do, and then decide, then see whether is it worth to hire, or maybe it will be good to actually get interns but supervised by experienced folks. I think that will help to manage the cost and create that momentum of building up the capabilities. Yeah.
On this topic, can I add one more? I'll call it like a cautionary tale that
Please.
I've personally experienced. Okay, so when people are doing machine learning modeling, you should be really, really focused on the data, because that essentially makes or breaks your performance. One time I've seen in an enterprise situation where essentially the data scientists were building their own pipelines from the data and not working with engineering to validate that everything was coming through. So they trained the model all looked good. They had to then go live and use it to start targeting customers for something. What happened then was we came in and started doing like an engineering audit of what was going on with their pipelines and their data pipelines. We essentially found that one of the columns, let's say they're using 5,000 columns or something in a table to use as part of their feature generation stuff for the machine learning.
Mhm.
One column was accidentally, it was being passed in with comma separated, and there was a comma somewhere in the column. So everything from that point onwards was just a null value. So like, let's say that was the 50th line, the 50th column in a 5,000 column data set. You've just lost 90% of your data. And it wasn't picked up anywhere.
Wow.
And these are the sorts of stories where like you don't really hear the data scientists talking too much about it, because usually you have the data, it's all good, you run the thing, the model goes well, and you ask for a promotion. So when things go wrong, I think those are the situations where people learn the most. And we should share more of these types of stories with the community to let them know how important validating their data is, being able to understand what certain things mean. Maybe being able to understand data schemas and different validation types would be perfect. These things, they're rarely talked about in any machine learning focused curriculum or course or anything like that. But when you go out into the real world and start playing with machine learning in the wild, it's literally the thing that can make or break you. So yeah,
I'm gonna give a shout out to on that note, I'm gonna give a shout out to some friends. Great Expectations, great library, checks for data quality, schema quality, etc. Run tests on your data before you use it, and then also Feast, Feature Store. So I think these things, you're gonna see a lot more advancements, in these areas. But I think just picking up on new techniques like these, I think will, at least hopefully help avoid the horror story you just described, because that sucks.
I have a more general question, if I may, just because we have just a few minutes left. You are all teachers or educators or mentors. And my question is, what are the most common mistakes and or most common challenges that you encounter with your students?
I'll go first. Usually it's sometimes it's a belief thing. Like they believe that it's really, really difficult to actually become a data scientist or learn specific skills because everyone else is saying how difficult it is. So some of those are like almost self-limiting beliefs that they've put upon themselves. And another component would be they've worked really hard for a really long period of time and they're not seeing enough results for them to actually believe that they can do it. And a lot of these things come down to more of like a higher level strategic thinking of how you want to tackle some of these problems. So if you're trying to become a data scientist, for example, you should work backwards and try and figure out, okay, which company do I want to work for? What skills do I want to demonstrate? How best should I demonstrate these skills? A lot of the times where like I see a lot of advice on social media and different places telling everyone just to keep going, learn everything, read everything, and somehow you'll absorb the knowledge. But how do you demonstrate that you understand the knowledge? And a lot of the times when I work with these people, they don't have a project portfolio to share with me. They have a CV which lists out some of the certificates, which is great, but I still don't know whether they've got the technical experience, if that makes sense. So most of the time we usually see like not enough projects, portfolio projects that demonstrate core skills. And then sometimes when they do have those projects, it's not quite up to the scratch or the quality that we would want to see as hiring managers. So it's just knowing a few minor, they're essentially minor things, but things which can make a lot of impact. Just knowing a few of those tricks will help these people really upskill and manage to land their roles that they want, for example.
And is the quality concerning the complexity of the project that maybe they've worked on, or is it just how they're presenting it, or?
I would say it's a bit of a mix. So sometimes people, there's two ends of the spectrum. One is go find and create your own data sets, which is really cool. And you can try and analyze your steps, for example, your daily steps, your caloric intake or different things like that. And then the other end is, go find a data set from Kaggle and just start using it and start doing all the things that everyone else has done. So it's sort of like a spectrum between doing something which is totally unknown and unique to you versus something where everyone's done it before. So how do you differentiate yourself best? Finding some sort of sweet spot in between is the challenge.
Thank you, Danny.
Yeah, that was a wonderful answer. Thank you. Anyone else regarding mistakes or challenges?
Obsessed with machine learning. Number one thing. People are obsessed with machine learning. I've been in analytics for 10 plus years now, been doing hands-on analytics for years. My top skill still is SQL, number one, right? Can I get data? Can I query databases, whether that's a traditional database or some sort of big data platform? Either way, they have SQL interface. Can I get the data? Can I massage the data? Can I clean the data? So that's number one. Number two is I do what I call KPI analysis using a form of a control chart from statistical process control. That's a wildly useful thing for any professional. Market basket analysis, the mighty random forest. I mean, you don't need that many things, and they're not that complicated to get disproportionately far if you're interested in actually solving real business problems with data. If you're interested in getting a data scientist job at a FANG company, then that's a different story. That's more like what Danny was talking about. But the number one mistake I see people make is that they assume that being a data scientist or being a data professional equal data scientist title at FANG company. And that's actually completely false.
Mm-hmm.
Thank you. All right, now that we're coming to a close here, I just want to ask each one of you, what do you have going for you?
I think Joe and Ko just unmuted themselves.
Oh, I'm sorry about that.
You wanted to say something.
Oh no, I just wanted to add another vote to what Dave mentioned
please.
the focus on machine learning. I think if not only for those people who want to get into the profession, but also for those people who are in the business as well. So say, hey, data science is very sexy. I want to do machine learning, and the next step and the next thing happens is, here's my data, work some magic out of it again. I was like, So a common example I give people is, when it comes to data, right, is I was ever approached by a potential client. I'll put it in client. So what happened was, they say that, hey, I like to do some forecasting, and here's the data that I have. So I said, okay, sure. Look at the data. I was given 3 months worth of data for forecasting, and I asked the person, so can I just share with you, like, how far forward you want me to forecast? 1 year. I was like, okay, sure. Let's see what kind of magic I can work out. But of course, I can't do any at all, because I don't have enough data and all this. But yeah, the strong focus on machine learning and the lack of focus on data quality and data management, I think that's something, that's a challenge. Yeah. Over to you, Joe.
Well, I would just close out with that, with saying that the career advice that I give a lot of people, whether they're students or not, is just zig where other people are zagging. Take risks. Data science, for example, it's very crowded right now. Maybe there's something else that would be more interesting, that would play to your talents more. I think understanding like what you want to do in life is incredibly important, and you shouldn't just confine yourself to this box that I need to be a data scientist, right? There's a lot of options you can take within data that will probably, it might require some soul searching to understand what you are really good at. But I think playing to your strengths, and maybe again, taking the riskier path is maybe the safer path. At least you'll have more interesting things to talk about with people too. So, but I've always been a fan of taking a very unconventional path. I think it leads to, and don't be scared of that, because you might find that the path you're taking could lead to some very interesting, and awesome outcomes for you that a lot of people wouldn't be afforded. So I think all of us took risks, right? Kind of going out on our own and, taking the road less traveled. I think we're all happy for it. So I'd urge people in their careers to be careful who you listen to, including us. So just, listen to yourself. What do you want to do?
Wow.
And do that.
That's life advice.
Yeah. Yeah, and that's something that I've noticed with each one of you. You give a lot of wonderful advice, not just technical, but like Diana said, life advice as well.
And unconventional, and I think that's very welcome.
So let us know what is going for each one of you. Joe, what do you have? What's upcoming? A presentation, a course, a webinar? What are you looking forward to?
Oh, geez, I got a lot going on right now. Growing ternary data, growing quite a lot right now, and then got a second full-time job writing the fundamentals of data engineering for O'Reilly. So that'll be out next year. So
congratulations!
Thanks. Yeah, it's been a lot of fun. Also teaching a course at the University of Utah, and trying to get out rock climbing as much as possible. It's getting to season, so probably a million other things I left off the list, but apologies.
So where people can find you on LinkedIn? Anywhere else?
I'm on LinkedIn. I ditched most social media. Tired of hearing my crazy relatives rant about really dumb stuff. You can find me on LinkedIn. That's the only social network I'm on. YouTube, Ternary Data. Don't go to my personal ones. My kids have co-opted it to put all their Minecraft videos on it. So don't go to my personal one. Go to Ternary Data. We'll be having a podcast, I think, as soon as next week. So stay tuned for that. But yeah, LinkedIn's the easiest place to find me.
Thank
Amazing.
you, Joe.
Thank you.
Yep.
Danny.
All right. Thank you again so much for having us on the show, George and Diana.
Such a pleasure.
So I run the Data with Danny Slack community. So everyone can feel free to join. We've got, I think, 2,200 people on there now. So I'm really busy trying to interact with as many people as possible on there. I'm also finishing and finalizing the launch for my very first online course called Serious SQL. So it's been in a beta testing phase since I think mid-February. So it's been a little while, but I've been smashing off the rest of the content and really refining the value proposition of what's going on inside. So it's supposed to be like it's going to top the SQL resources offered by Eric Weber. So watch this space. That's my number one goal at the moment. But I'm busy trying to finalize that for the launch on the 26th of April. And I'm going to try and do like a new hashtag community style thing as well. So it's going to be like a hashtag 8 weeks SQL. Oh wait, no, I got it wrong. 8-week SQL challenge. So I'll make some social media posts about that. But essentially I challenge everyone to do my course and learn more SQL in 8 weeks and see where you end up on the other side.
Fantastic.
So hopefully that'll be cool. A fun social experiment. And I'm trying to repurpose some of my old live streams to upload to my YouTube channel, which is, I think, just YouTube Danny Ma. So feel free to hit that up as well. But yeah, please check out my website, datawithdanny.com. I need to fix that dark mode, light mode thing. But hopefully it'll be fixed by the time you visit. So thank you again so much.
Fantastic.
Amazing. And also, Danny, thank you very much for replying to some of the questions that we had in the chat. That was very helpful.
Appreciate that.
No worries.
Cool.
You're on mute, and we do want to hear
Okay,
what...
sorry. I'm going to give a talk, I think next Wednesday, Singapore time. And I'm going to give a very unsexy talk on data collection. How do you do good data collection and all? Very unsexy. So that's at a conference called API Days. So if you're interested, can PM me on LinkedIn. While I'm also writing up my blog again, so I'm sort of writing a bit more blog post articles, and also working on my podcast as well. So if anyone wants to follow the content that I put out and all this, feel free to link me up on LinkedIn. Follow me on LinkedIn, and I'll post those new articles or podcast episodes that I've put out. Yep.
And here we
Beautiful.
can mention that
Thank
you are
you.
a LinkedIn top voice,
Oh,
which is
That
one
one,
of
yeah.
George's not so subtle goals.
Okay. Yeah. Yeah. Thanks.
See, it's
Congratulations.
the modesty. It's the modesty
Yeah, I know.
right? Yeah.
Then we stand no chance.
Yes, exactly.
Thank you.
Thank you, Koo. And Dave.
So these days, I really focus my efforts on giving data analysis skills to any professional. So whether you work in IT or HR, finance, marketing, whatever, supply chain, doesn't matter. All I do is I focus on people that have basic Excel skills, and I teach them more advanced analytics. So I've got a bunch of stuff coming up. So I have a webinar on the 28th talking about how folks can go from analyzing data in pivot tables to using the mighty random forest, using a subset of machine learning to analyze their data. In early May, I have a live training course on how to do KPI analysis using statistical process control techniques.
And where can people register for those?
So the easiest way to do it is just go to my website, daveondata.com, and just hit the live training tab, and then all that stuff's listed. And then this isn't announced yet, so this is a brand new announcement just for Lights on Data.
All right.
In June, I will also be teaching a live course on linear regression analysis using Excel based on a LinkedIn poll. It will be 3 Saturdays, so in the morning, so people in Europe and in India can also make the time as well if they would like. So that's what I got going
I
on.
need that.
Nice.
I might see you there. I'm doing my PhD, so this is something that I will need.
I can teach you
See you
data
there.
analysis, Diana. I can do it.
I know. If I trust anyone, it's you.
Sweet. Thank you.
Fantastic, everybody. Well, thank you so much again for joining us. And yes, on the Lights on Data show, we really appreciate you and your time. And definitely everybody that's watching this as a recording or live, please make sure that you follow each one of them because they have amazing things to offer.
Thank you. Thank you, everyone.
Thank you, everybody.
Bye.
Bye.